basically we have done number one. We have a volunteer here looking through this. What kind of compound did I give you here? Ionic or covalent? Covalent, because you can see the prefixes in there and everything. You just read it straight. Go on.
Keep going. I got it for a second.
So I will read his mind. He said, okay, first step we're doing is molar mass conversion. We would take our grams to moles, and he's writing out N2O for me because it does matter. N2O on the top and the bottom. Because whenever you change identities, you'll notice the question says convert from dinitrogen monoxide to nitrogen. I need to know which one you're talking about at that point in time, so that the identity of this substance does matter. So after the grams and grams were converted to moles of N2O, then so tell me what you did here.
Oh, there's two molecules of, I don't know, that's not the right word for molecules, but there's two molecules of nitrogen and 2O, so you do that. So that's the coefficient.
So the internal mole ratio
Yeah.
deal. So there's a subscript of 2 there, so it becomes the coefficient representing 2 times the amount of N's in 1 NO or N2O. And I'll do it another way in just a second that I think will make sense as well.
That's a 3.
So it's like 1.8.
1.8 times 20. Atoms of nitrogen.
Okay, cool. Thanks. I'll still talk. Okay, thumbs up if you got this far. You got this. Right, that's less than half our class. Okay. We need to keep working on problem set 10 a little bit more. Maybe tonight you can redo some of them and double check yourself if you made that 3 or 4 days ago. Whenever you get to the point where you're like, okay, I know I can cancel grams and grams. You know that the grams are going to go to moles. You should be easily getting there. The next step has 2 different paths you can take, and either one are equally appropriate. They will both get you the correct answer. So instead, you could have maybe lost a marker. Oh, that's all right. Marker is gone now. Okay. So here you could have done 650 grams of nitrogen dioxide to 1 mole of nitrogen dioxide, 44.02 grams of nitrogen dioxide. What's the second step you could have taken here instead of going to the internal mole ratio part? Yeah.
Could you have done,
Anybody?
could you have done, like, turned it into atoms?
Not atoms. Atoms is the inappropriate word for that particular substance.
It's on your label.
I know the atoms are, oh, is it?
Yeah.
Thanks. Okay, sorry. Atoms are used for just simply element. For elements.
Oh,
This is a
molecules?
molecule because this is a covalent species or covalent compound. So you said take 1 mole of nitrogen dioxide to what?
To 6.022.
Times 10 to the 23rd what? Molecules
Yes.
of N2O. Some of us are like, okay, I've got a huge mole of this stuff. Now I want to get down to 1 molecule of this stuff. This stuff, though, is a molecule. So just visualize the molecule. What does it look like? What's bonded to what? Right, we've got a nitrogen bunch, an oxygen, something like that. Okay, so then in one of those molecules, in one molecule, remember a molecule is not a mole, how many atoms of oxygen are there? Nitrogen. Atoms of nitrogen are there. 2, because it says in N2O there are 2 nitrogens in that molecule. So that's 2 atoms of nitrogen. So what's the only difference between Jacob and my method here? Practically nothing. The units are all the same. They're just in different places. So we went internal mole ratio here and then to atoms of atoms of nitrogen, versus here we went to molecules and then to atoms. The methods are equal. It's just choose your favorite. That's it. Okay, so then the answer is still blah, 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 blah. 1.8 times 10 to the 25th atoms of nitrogen. All right, tell me how you guys started the second one. Yeah.
So, you base it off of like 100 grams zinc.
Okay.
And so you would do, the carbon would be 40 grams, 40.0.
Okay.
Yeah, and then first you have to find oxygen.
Okay, so I'm going to write 6.7 grams of hydrogen here. Tell me how much oxygen's there. Everybody should go tell me. 53.3. How did you do that?
100 minus.
Okay, so 100 minus 40 is 60, minus 6.7 is 53.3. Okay, we're in grams of everything. go to,
Mole.
well, to get to empirical formula, you have to get to what unit here? Moles, and then we're going to take those moles and do what with them? Divide by the smallest, and that gives us the ratio, which are the subscripts. Okay, so everybody have a calculator out. Make sure you're working with me here. 1 mole of carbon weighs what? 12.01. Half of us are like not even looking here at table anymore for that one, right? We've used it so much. What's that moles? 3.33? Okay, moles of carbon. All right, next one. What do I do?
1 mole over 1.00.
1 mole over 1.008 grams. Okay. That's about what? 646, something like that is what I heard. Okay. And last one. What's my molar mass? Okay. 1 mole of oxygen is 16 grams of oxygen. And our grams and grams have canceled all the way through here. I just didn't actually cancel them for you. Okay. And then that is 33. I'm stopping there. Okay. So at this point, we don't have subscripts yet. These are the full moles of everything we have. To get the ratio, you do the whole greatest common factor, lowest common multiple, whatever it is in math, right? Basically, when you divide by the smallest number of moles, it gets you the simplest ratio. So what are you dividing by? 3.33. So if you just write /3.33 like that for me, about the mole, I get it. Okay, so what is the first one? 1. Second one? 1.99 something. So 2. And next one? 1. Ratio? CH2O. Imaginary ones, right? What kind of biomolecule is this? Before I take your question. Huh? I heard something. It's glucose, right? But it's a carbohydrate, because glucose is a carbohydrate because it's in a 1 to 2 to 1 ratio. Okay, question.
I did like instead of going to 53.3 grams of oxygen, I did 53.3% of 60.
Because it's 60 grams was given to
Right.
you. That's totally fine. It's just would have to do the same thing for all the other ones as well.
Yeah, and then you just divide them by their molar mass.
And you got the
Gets you the unsimplified.
Right.
And you simplify it.
Right. There's multiple ways to do it. I tend to stick with one method because if I show you guys 5 methods and say choose, sometimes you mix them up. So I stick with one. If you know what you're doing, stick with it. But if you like this method, this is the best method that I will always use. Okay, so this is the ratio, but then we have to consider this, and that's what Jack was saying. This substance total weighs 60 grams. Well, this substance does not weigh 60 grams. What does this weigh? Add this up in your head. You do not need a calculator for this. Huh? How much does carbon weigh? So 12-ish plus 2 is 14 plus 16. 30 grams per mole. I'm expecting you can do simple addition in your head. Okay, 30 grams per mole. That is not 60, but how many times would 30 go into 60? Twice. So then what's the multiplier? 2. So see how we actually did the whole MF formula mass over EF formula mass in our head. And if you just write that like this for me and say my multiplier is 2, I get what you're doing. Okay, so some of these methods can be simplified. But what would the molecular formula be? There we go. And that weighs 60 grams. So what do we do in our head? We just did 60 grams per mole over 30 grams per mole, and we got the multiplier of 2, and then we applied it here to the substance. Okay, so I think EFs and MFs are usually easier once you get the method down. Your main focus tonight can probably be looking back at the whole mole relationships with molar volume, particle numbers, and molar mass conversions, and how to piece that together in like a 3 to 5 step process. Some of these things will be 1-steppers. Some of them will be 2 and 3. There are only 6 or 7 questions on the quest, though. It's a quiz test, right? It's not a test. It's not a quiz. It's a little bit longer than a quiz. So, study. All right, so before we go to our CSI investigation, somebody has been murdered. Dun, dun, dun. Okay? You are leaving for me on your desk. Make sure it's visible for me. PS10. Oh, hold on. I'm sorry. Before I do that, let me go over PS10 questions that I promised I would go over. I'm sorry to just just tease you. Just a teaser there. Okay. Question. I'm starting with question 18. Everybody check with me, okay? Question 18. Here we go. How many atoms of hydrogen are in 4.56 grams of ammonium sulfate. So, how many grams of hydrogen, or let's say atoms, it said atoms. How many atoms of hydrogen are in 4.56 grams? What is ammonium sulfate? Do not look at your paper. NH4, SO4.
There's a 2 after that.
There's a 2 there because you crisscross it down. This should be second nature to you. Okay, so what are we starting with? Starting with 4.56 grams, the only number we have, right? Starting with this many grams of ammonium sulfate. Can't do crap with grams. What do? You have to go to moles, right? Convert to moles. Go with moles on top of ammonium sulfate. What goes on bottom? What's the total mass? I remember it being 130 something. Do you concur? 1 grams of ammonium sulfate. So how many nitrogens did you add up? How many nitrogens were in that compound? How many hydrogens? 8. And how many sulfurs? 1. And how many oxygens? 4. Okay, just make sure we distributed that 2 over. Okay, so then grams and grams cancel. Now we're in moles of ammonium sulfate. I don't care about ammonium sulfate though. I care about what? What do I want to get to? Hydrogen. So I've got to start pulling this thing apart. Do you guys recognize, what kind of compound is this? It's got polys in it, right? So polyatomic ion. So what kind of compound is this? Ionic. All right, so I can pull this mole down to what's its subunit, what's its formula units, right? So 1 mole of ammonium sulfate has how many formula units in it? Avogadro's number. Anytime you're going to particles, you're using Avogadro's number. 6.022 times 10 to the 23rd formula units of, I know this is really tedious, it is for me too, to write out ammonium sulfate, but there it is. Okay, so now we've gone from mole down to just a little formula unit, just a particle. There it is. How many are actually, how many atoms of hydrogen are in this one particle? 8, because the multiplier of 2 applies to 4, so it's 8 atoms of hydrogen in that particle, in that formula unit. So then how do I write that here? 8 what? Atoms. We're going to atoms. How many atoms of hydrogen? There's 8 atoms of hydrogen in, let's just call it for easiness sake, we can call it a molecule because I think you understand the term molecule better than formula unit, but the formula unit is just the appropriate term for a salt, for an ionic compound. Okay, so add 8 atoms of hydrogen over 1 formula unit of ammonium sulfate. You really have to think about how do you get from moles to particles, and then what does the particle represent? It represents one of these with 2 atoms of nitrogen, 8 atoms of hydrogen, 1 atom of sulfur, and 4 atoms of oxygen. You easily could have done this again with the mole ratio, internal mole ratio. I just want to show you guys this way so that you understood there are multiple ways to do this. Answer? Times 10 to the 23rd atoms of hydrogen. Cool, yeah. Of that? So you multiply that by its percentage and then went to, that's totally fine too. It's just, we're going to be using stoichiometry a lot, so I practice this way, but you can also always represent if you know the percent composition, use that to get to grams, use the grams to get to moles, and then to atoms. Totally fine. Like I said, like sometimes 5 ways to do something. Okay, 16, I heard 17. Which one do you want me to do? I think those are similar. I might be lying. 16 or 17 right now? 17, nitrogen, oxygen, molecular mass is 91.8 grams per mole. What's the molecular formula? Okay, you guys remind me of these numbers. 30.5 and 69. 30.5% and then 69. And this was oxygen?
Yes, oxygen.
And nitrogen?
I'm sorry.
No, nitrogen. Okay. And oxygen. Okay, what do I do with those percents? Yes. similar. Okay. So I will speak for her. She's a mute right now. So she said, assuming 100 gram sample, so percents go to grams. Keep going. We can lead you here. What's your next step? So you guys tell her the molar masses, maybe? That might be helpful. Somebody has a calculation for her? 2.177. Okay, moles of nitrogen. That's a nice question. You guys do this? And guys, with that, alright, so what does she do after this? Remember, she's going to molecular formula, didn't she? Okay. Divide that by itself, and what is that? I know it's hard. What is it, guys? One close one there. So, probably 2 is probably right. Okay, so the ratio is... Okay. If you had to name that as it is, what's the name of that? Okay, nitrogen what? Dioxide, and then the molar mass of this substance was given to us as 91.8. 91.8, okay. What's the molar mass? What is the mass of this right now? You can add this up in your head. So 14 plus 16. Okay, so 46-ish grams per mole is looking right. Just because I can estimate better. So this is the empirical formula mass. What was the mass given to us? 91.8. That's about 92 grams, right? How many times does the empirical formula go into the molecular formula mass? About twice. So this would be, instead, what? Name that. Tetroxide. Right, dinitrogen tetroxide. Okay, yeah.
I did mine different and I got the same answer.
Like I said, there's probably 5 ways to do something. You want to share your method?
Yeah, I did. I just divided the 30.5 by 30.5 and then 69.5 by 30.5 and I got 1 and 2 and then I did that and I got the 91.8 and divided it by the 46. Because the 46 is it all together.
Is it all together? The only reason that worked is because that last step you did, but generally you cannot do mass ratios, you do mole ratios. So when you divide the percentages by the percentages, that's a mass ratio, and that will lead you astray later on in life.
Okay.
That can life,
Okay.
but you know. But just if it works for you, I think it should work, especially that last step you did. Okay, oops. Hold on to your last questions on problem set. Keep them on your desk. I want to see what you got done. Simulation, I will check that and I'll give some feedback at the end of class. But we have a problem to solve, people. Put your red board pants on. Let's do this. So, what we're going to do is, let me tell you about I hope you guys brought your big board pants today. I just don't know on my paper. I have to read something to you first and then we will go and solve our crime. So, you guys probably saw there's been a crime scene set up. There's a man on the floor. He died from chemistry, but not from doing chemistry.
Me. That was me. That's me.
So let me read to you about the investigation before we begin. I will wait on you. Thank you. Okay. The victim in the following case is a 35-year-old male named Tony DeMoy. Did you guys know?
No.
Me neither. Initial investigators say that they found several signs around the death site that suggest foul play. 4 possible cases of his untimely death have been suggested by his wife, who has been ruled out as a suspect because they've proven alibi. So it's not the wife. Everyone goes straight for the wife. It's not her. All right. Your task is to identify who and what killed Tony DeMoy. The first scenario, there's an unlabeled drug bottle. He was going to this sketchy doctor, and they gave him some experimental medicine. It's on the back table. Don't touch it. It's a part of the crime scene, people. Right? Don't mess with the crime scene.
Tamper with evidence.
Yes. Second scenario. There were some partial fingerprints retrieved from a tipped cup. The cup's in that place someplace. Okay, do not miss the cup. But somebody might have poisoned him, and a disgruntled neighbor may have given him a little something in that cup. All right. case or scenario 3, his wife mentioned that he had osteoarthritis, and he was popping painkillers like candy. Okay, maybe something dangerous was in those painkillers. Scenario 4, he was a brilliant chemist, aren't we all? And his undergraduate research helper may have killed him through, or with reasons that are untold, but they were working on some brilliant research together, and he might want all the credit. Dun, dun. Okay, so you have to assign one person in your group as the CSI liaison. And you ask who I am? I am your lead investigator, and I have the autopsy report to tell you how he died. But you must prove to me your CSI skills by going through and figuring out what the chemical composition of these compounds are. What does that mean? Find me. What if we just molecular formulas, okay? You'll be working in teams of 2 or 3, up to you. Only the person wearing the badge that's going to talk to me about what the problems are that you were having. Okay? First step, grab a calculator, grab a piece of paper, form groups of 2 or 3, and go to a spot.
Jordan, you ready to stop this time?
Skylar with us or is she with look at her coming up.
You literally have 2 friends.
No, everyone's right. This is it. Oh, I forgot to tell you. Announcement. Time is of the essence. Because you get paid big time for this, for getting this right. And we don't play with real money, but with no money, which is even better than real money. Right? So you get paid for getting this correct in a timely fashion. Go. Everybody needs paper. Everybody needs paper. No. You have to have evidence. You don't get to know. You need to be
I hate it.
You should be going on to question 2, to scene 2.